So now we're going to see in instruction. In instruction, microprocessor is going to communicate with input output device. But in means it is going to communicate with any one of the input device. So that one input device is available in address 80. So consider in keyboard you are typing some content like 45 you are typing. In microprocessor, accumulator is consists of some value that we are not going to worry about it. What after executing this instruction, what happens is that in means microprocessor is going to take inside, okay, 80. That means whatever the device, input device which is connected in the address 80, whatever the content they have typed, that content will be moved to microprocessor. Okay, microprocessor in that accumulator. So after executing this N80, what happens is that your accumulator will carry whatever the content you have typed in the keyboard 1. Why keyboard 1 means which is connected in the address 80. Instead, if you have mentioned in 81H, consider like that. Okay, if you have typed like this, then consider your keyboard 2 is connected in address 81. Okay, here you have typed a content 5A, then this content will be moved to accumulator. So in 81H na, in keyboard 2, whatever the content you are typing, which is the keyboard 2 is connected in the address 81. So this content will be transferred to accumulator. So did you understand what is in 80, in 81? I want me to repeat this. If you want me to repeat, please mention repeat in the chat box. Okay. This in instruction, it's similar to your LDA or SCA. Just relate this in instruction with LDA or SCA. Yes, Iba, you are right. Kannan, think and answer. It is not relevant to SGA. Okay, so generally in LDA, what you will do? Consider memory, microprocessor. From memory, you will transfer the data, loading the data. In which instruction, Kannan? In LDA or SGA, you will do from memory to the microprocessor. LDA. Similarly, from input output device to the microprocessor, from output to input, from the outside device to the microprocessor, which is nothing but in instruction you are using. So your in instruction is similar to your LDA instruction. Now you have understood, Kannan? Okay. Now in instruction, if you have understood, tell me about out 83. Out 83. Consider your microprocessor. In microprocessor, accumulator consists of 5A. Now tell me out 83. 83 means in 83 monitor is connected. Consider 83 monitor is connected with the microprocessor. Very good, Satvik. Tell me what happened. Out 83. At 83 monitor is connected and accumulator 5A is available. Yes, Kanan, you are right. Accumulator content will be sent to the address 83. In 83 monitor is connected. It will display 5A. Very good, Satvik. Very good. Okay. So monitor will display 5A. So I hope you all understood what is in and what is out instruction. Okay, so your out instruction is similar to what? Okay, your out instruction is similar to your STA. Okay, listen. Now, how many T state, how many mission cycle it is going to carry, that we need to know. Here 2000 in the address in 80H is available. In is nothing but what, ma? According to the mission cycle, in is nothing but what? Opcode. Very good, Kanan. Opcode fetch. Because it's an operation. In taking it in. Opcode fetch. Okay. And then next 80 will be in what address, ma? 80 will be in what address? Yes, very good, Kanan. Okay. A8 to A15. Ma, Hiba, I am talking about like this. I want you to write at 2000. What will be available, ma? At 2000. First, tell me at 2000 what will be available, Hiba? I'm not getting, Hiba, what you are trying to answer. At 2000, what will be available? Kannan? Oh, okay. Okay. Otherwise, I will ask like this. 4500 LDA. Something called 4700. In 4500, what will be available, ma? Yes, Kanan, you are right. Yes, Iba. The same thing here I am asking. In 2000, what will be available? In 4500, LDA mission code is available, na? Similarly, at 2000, in mission code will be available. Okay. In is a opcode fetch. Okay. So consider some double X will be available. Generally, we will mention double X. No, if you are not aware of that mission code, we will mention double X. So always you can answer double X. Okay. Then in 2001, what will be available? Hiba, 80 will be available, ma. 80, that H is nothing but hexadecimal value. It's a hexadecimal value. In order to show that 80H, it's a hexadecimal value. So 80 hexadecimal value will be available in 2001. So any doubt in this? 2000, 2001, any doubt? Kannan? Satvik? Okay, ma. Okay, up to this. After 2000, the next address will be 2002. What? Yes. Yes, you are right. Next instruction address will be 2002, Iba. If you are going to write one more line, then that line address will be 2002. Okay. So this x-axis according to mission cycle. According to mission cycle, this x-axis what, ma? According to mission cycle, what mission cycle will come for x-axis? Opcode fetch. Very good. So at 2020, which is nothing but 2000, at 2000 double X. Here they have mentioned DB. This DB is the exact mission code for that in. But you don't need to remember this. Okay. So you can put XX Any doubt in this up to this opcode fetch? Any doubt? Okay. Then next, at 2001, 2001, 80 is the value available. Okay, let it be. So I hope this is, you are reading this address 2001. So memory read, opcode fetch, memory read is over. Then why IO read means, because whatever the content you are typing in the keyboard, that you have to read. Then only that content will be transferred to the accumulator. Am I right? Ma, in 80H, consider in 80H na, what machine will understand? In means what? It is going to take it from keyboard. That it is understood. And in which address, ma? In which address? In means it is a Satvik. At present, I am explaining about only in 80H, ma. I'm not talking about output and all. Only in 80H alone I am considering this. Okay, this timing diagram is for only in instruction. Ma, once I will repeat, please understand. In 80H, in means what is the, what machine will understand, ma? After reading this dB of in, what it will understand? Okay, ma, opcode fetch, that is okay. In is nothing but operation. What operation? It means read input. It must read input. That is what it is understood. Okay. Then you have to give the address from where it has to read. Am I right? Okay. So address is what? Here, what is the address they have given? Hiba, listen, that no, 2000 consists of this in opcode fetch. From where you have to read 80, as I have drawn here, look here. This keyboard is connected in the address 80. This keyboard too is connected in the address 81. So that 80, 81 and all address of that input output device. So now tell me, after understanding, okay, it has to get the data from the input device is understood. Then that particular address is what? Kanan, what is the particular address? Address of keyboard. What they have mentioned in the instruction. It must read input. Then, okay, 80H. Okay, so in this address, that keyboard is connected. After understanding the operation, it has to read, and after understanding from where it has to read, whether the operation has been completed. Ma, I'm giving you a task, ma. Listen, go to the room, get that book. Like that, I'm giving you the task. So, what are the information you got from me? Room and book. These two information you have got. But you have completed that instruction. Go to the room number 200. Consider room number 200. So you have understood, and you're going to get the book. That also you have understood. But you have understood, but did you complete the process? You have not completed the process. So here After understanding this process, you have to complete the process. The machine has to complete the process. So at 80H, what content is typed by the user, that content, what they have typed in the keyboard 45. So it needs IO read. So it will read the content available in the input device. Then only it is completely done. It is in 80H is completely done. Now we have understood why they are going for input read. Kannan, is that confusing for you? Okay. Hiba, now you have understood, ma? What about Satvik? Did you understand? Hiba, why don't we have yes, writing the key on data is 8085. You are asking input output read or input output write. Instead of input output read, why not input output write? That is your question. Am I right?
Sir, over there, that WR instruction is there, right? Below the RD bar.
Yes, WR instruction is there.
Why aren't we having any, like, up graph or low graph over there? Because we are writing the K1 data in microprocessor, right? In the accumulator.
Yes, in microprocessor you are writing, but already I have told you, we don't have an instruction called register write, accumulator write, like that we don't have, no?
Oh, okay.
Okay, I will show the various instructions, various mission cycles. What are the mission cycles available is that one, memory read, then two, memory write, then IO read, IO write. Okay, but among this, did you find anything called accumulator write or register write? Okay, so we are not going to mention this one, because finally it is going to store it in accumulator only. Whatever the data available in this address 45 is going to store in accumulator. For that, what you are doing is that you are reading the content available in the keyboard. That itself nothing but storing the content in the accumulator, because you are reading a bookmark. Okay, so you are reading at the same time it is stored in your brain. Am I right? The same operation is has been done here. Okay, so here whatever the content available in the keyboard that you are reading. Keyboard means input output read only, no? Okay. So here 2000 in 80H. So 2000 to 2000 XX, then 2001 80. Output fetch, so opcode fetch, memory read is over. Then here this address, in this address I need to go there and get the data. What is the data available? Okay, 80 is the address. Generally LDA 4100 na, here 41 will be available, here 00 will be available. But this address is how many bit address, ma? This address is how many bit address? So 8-bit address. So 8-bit address, one more copy they will load here. But anyhow, it will take only this one. It will not be considered like 8080. This address line is it should they are not going to keep that empty. Here 80, this address is sufficient. Here one more 80 they are loading, but it is not going to be considered as a 16-bit address. It is generally 8-bit address only. Same copy they are loading. Okay, so 80 in this address, this will be taken. Data from the port. Data from the port, na, they are mentioning Port means what? Through that part only we will be taking the data. Port means via, like airport. What does airport means? Through the air they will be transferring the data, transferring the person from one place to other place. So that is why it is airport. Similarly, port means through this port we are transferring the data. So here they have mentioned data from port. Here actually 45 is there. Then what I should replace? Data from port. What I should write here? The data. What is the data? 45. Kannan, did you understand this? Okay. And one more thing, if you are not going to use the right operation, you can you no need to draw this straight line, or else if you like to draw, you can draw. That's not an issue. Here I'm not going to use any input output right operation, so I'm not going to worry about this right operation. And did you understand why here ALE, here ALE, here ALE is high? The purpose of ALE here and all, why it is high, did you understand? Satvik have understood. What about Kannan and Hiba? Okay, Hiba have understood. This 80 we are mentioning, it is a address. This is not the data. This what here this 01 is a address. It's not a data, because since this carries address and data, it will get confused whether it is address or data. This 00 is what? Address. So I need to mention address. This 01 is address. So I need to mention it is address. So that is why that AL is 1. Very good. Then again this 80 is also what? 80 is also what, ma? It is also address. Yes, Jaswant, right. When this data is coming, ALE won't be available because you are reading the data. And don't do the mistake. 1 second, ma. Don't do the mistake. Here in a flow you may write memory read and memory read, but here you are communicating with what? Microprocessor is communicating with what, ma? Input output device. Okay, so input output read. So now tell me 2500 out 83H. What and all I should replace? Tell me here what I should write. $25. Here same 00 because 2500. Okay, then what I should write here? XX. Okay, very good. Then what I should write here? 25. Then here 01. Okay, right. Then what I should write here? Okay, 83. Out that XX, then next address 2501 83. 2501 83. Okay, then what machine cycle will come? What machine cycle, Kanan? Jashwant and Hiba. Okay, Okay. Now you are right. Jashwant, mission cycle ma. Mission cycle na memory read memory write input output read input output write. That is what I want. Satvik, think and answer. Out instruction, from where to where the data will be transferred. Kannan, you are right. From where to where? Accumulator to the monitor. Monitor is what device? Output device. Do you have input output read only or input output write also? Okay, Kanan. Finally, you're going to write on the monitor. Yes, Jashwant. Input output write. So replace this read with what? Write. So now, as what Hiba was, why not it will become low? Now it will become low here. This read operation will not come. This will come here like this. Now you have understood, Hiba? Okay. This will be straight line for IO write out 83. And data from port means what, ma? What I should write here? And what I should write here? First you tell me what I should write here. Instead of this 80, what should I write? Jashwant, you are right. What I should write here instead of this 80 for out 83? Satvik, Kannan. Okay. What about Hiba? $83 will come. Okay, 83 will come. Both in both A to A15, AD0 to 87, 83 will come. Then what will come here? Generally, how to say? Okay. Okay, Hiba, you are right. Yes, Satvik. Whatever the content available in accumulator, data to the port. Yes, Kannan. Whatever the content accumulate consists of the content available in the accumulator, that I am going to transfer it to the port, to the monitor. Understood? Will the input output memory be high line during all this process? Yes, ma. Because by reading this instruction itself in 80H, your data is not going to be transferred to the memory, or you are not going to get the data from the memory. You are just transferring. In means getting the data from the keyboard, which is nothing but input output device. So Everywhere this IO bar M bar will be high. For out also it will be high. Okay. So now I'll tell you one task. Okay, so answer for this. Consider one industry running person is there, industry owner is there. In that industry, they are going to fill 20 bottles with water. Okay, per day 20 bottles. Consider, or 200 bottles per day automatically. Okay, so they will be expecting this to do in 2 minutes. So you are the microprocessor programmer. They that industry people, they are asking you to do this automation. I want this bottle to be filled in what 20 seconds or 20 minutes, let it be. So are you able to do this, the automation with the what, this concept with the T state? This instruction will do this operation, this instruction will do this operation. So you will be able to do this automation. Consider you will be able to do the automation, but are you able to relate with this timing diagram? Are you able to relate with the operation, day-to-day life operation na within this minutes this instruction will be completed or not? Are you able to identify? Once I'll repeat the question clearly. Listen. Industry person are asking you to write a program to do it automation. That program should do this automation. That means in 20 seconds it has to complete that process. So you have to write a program to complete in 20 seconds. Are you able to know whether your program will complete in 20 seconds? Okay, tell me if you are know about what it will complete in 20 seconds. Can you tell me this out instruction will complete in how many seconds, ma? Tell me how many seconds this out instruction will complete. But we are aware, so we are aware of T state. Yes, you are right, Iba. So we are aware of T state. But will you say to the industry people that sir, for filling this bottle, this many T state it will take, this machine will take this many T state, whether they will understand? They will not understand my program concept and all, because I know the program concept, I know the T state by using the timing diagram, but they know only within this seconds or this minutes, because they are not aware of mission. That mission means microprocessor. So we need to convert this T state into T state into minutes and seconds, no? Then only you can exactly relate what this program will take this much minutes to complete. So this is suitable for doing this operation. Are you able to understand this process? Jashwant, did you got my point? Why we need to take care of this T state so that we can be used for this. Convert T state into second. That is what this concept I will for that reason only I have given this example, Iba. Next topic is converting that T state into what, minutes and seconds. Satvik, did you understand what I am trying to explain? If you have not understood, you can ask me to repeat. I will repeat. Okay. Satvik, actually, industry people, they are not aware of T state. But as a programmer, you are aware of T state. Am I right? Industry people, they required to complete the process in 20 minutes or 20 seconds. Consider one process, some process to be complete in 20 minutes automatically. By using microprocessor, I know my microprocessor is used for automation purpose. Okay, so my microprocessor, I'm going to write a program, but that program need to complete in 20 minutes. Consider the process also is going to complete in 20 minutes. My program need to complete in 20 minutes. Okay, but do you aware of my program will complete in 20 minutes? But I know my program will complete in this many T state. Am I right? Yes, out instruction will take what 10 T state ma. But when you are writing multiple lines, like first line LDA 4500, then move B comma A, then move B comma A, then next one MVI C comma 00, then halt. Just consider this 4 line as one program. For this, how many T state totally it will take? For completing this program line, how many T state it will take? First line, this many T state, second line, this many T state, like that you tell me, so that we can rectify the mistake. Don't add all the T state and answer one answer. I want you to say first line, this many T state, second line, this many T state, third line, this many, fourth line, this many. Like that you please mention. First line, okay. First line 433, okay. 13 T state, 13 T state 433. Iva, how come it is 13 T state, ma? What are the machine cycles, ma? Iva, listen here. Opcode fetch. This will be there in one address, memory reader. This will be there in another address, memory reader. That's it for LDA. 10 T state only, Iva. Because we don't have an instruction called accumulator write, because the data available in this address need to be stored in accumulator. But I don't have an instruction called accumulator write or register write. Understood, Iba? Okay, so opcode fetch, memory read. Totally 10 T state for the first one. Then next line, move B comma A. How many T state? What are the mission cycle? Yes, Iba, you are right. Kanan, what happened? Got confused? What is the mission cycle will take for move B, comma A? Only alphabets are there, man. Easily you can answer, no? Jashwant, Satvik, how many T state for move B, comma A? Yes, Kanan, you are right. Only alphabets are there, na? That will be opcode fetch, ma. Operation. Operation is mentioned with what alphabets. Okay. So here move B, comma A. So opcode fetch. Opcode fetch na always 4 T state. This is 4 T state. So here alphabets are there. That means this alone is 4 T state. Then this one is what? MVIC, comma 00. Yes, yes, you are right. This one opcode fetch. This is memory read, because consider it is there in address 4500 na. In 4500 opcode fetch MVIC will be available. In 4501 I am reading that memory address. At that the 00 is available. So 7 T state. Then halt. How many T state? Only alphabets are there. Simple. 4 T state. So totally how many T state? Seventeen, 21, 25. Yes. Kannan, did you understand totally how many T state it takes? It took 25 T state. Did you understand? Or any confusion in any line? Why it is 4 T state? Why it is 7 T state? Any confusion, ma? Add everything, man. 10, 4, 14, then 7, what? 21, then finally 4 T state, 25. For completing this program, 25 T state it took. Okay. So now I'm asking you to I'm giving a task to 2 person, ma. So 1 person, the task is count 1 from 10. For both the person I'm giving the task. Do you think both the person will complete the task in same time period? There is a possibility. There is not possible also is there. Like 1 to 10, 1 person will count 1, 2, 3, like that they will count 1 person. Other person 1, 2, 3, 4, 5, 6, 7, 8, like that they will count. So task is common, but how they are doing is different. Now tell me, your microprocessor completing this program line will take this much T state, but whether it is executing these line in what speed, it is depends upon what? Microprocessor operating speed is depends upon what? That is my question. Microprocessor operating speed is depends upon what? If you remember about the architecture, you will be able to answer. Jashwant, you are right. Very good. Others, I have given a clue. If you remember about the architecture, you will be able to answer for this question. Question I'll repeat, Kannan. At the speed of operating speed of a microprocessor is depends upon. Yes, very good, Kannan. Clock speed, clock frequency. Okay, crystal oscillator. Crystal oscillator is generating frequency. That frequency is, if it is high, your processor speed is high. If the frequency is low, your processor speed is low. And I have explained with your mobile phone. When you're going to buy a mobile, if the frequency, operating frequency is high, your mobile is going to work in high speed. If the frequency is low, your mobile is not going to work in high speed. Okay, so for completing this many t state, 25 t state, every one t state, one microprocessor is working with one frequency na, low frequency na, this 25 t state, it will take extra time. If my microprocessor is working in high speed, okay, high frequency, this 25 t state can be completed with what, very less time. Did you understand? As I have given one example, no, 1 to 10 is a task, but one person is counting like 1, 2, 3 like that. The other person is counting in 1, 2, 3, 4, 5, 6. Same task, but it is completed in a quick manner. Similarly, here 25 t state it has to complete. So for completing this 25 t state, my microprocessor clock frequency also is deciding the completion. Am I right? Are you able to understand my point? This one, 25 t state it has to complete, ma, but at what speed it is completing that 25 t state, that is also is depends upon or not. It depends or not. Okay, so that 25 t state is multiplied with your clock frequency. Now it becomes in terms of frequency, 25 t state into frequency. Now so it will give you in terms of frequency. So your frequency is nothing but 1 by time period. This is not a t state, it is a time period. So if I need time period na, in terms of seconds na, what I should do? 1 by frequency is equal to time period. Am I right? Are you able to understand? Frequency is equal to 1 by time period, ma. I want my answer to be in time period, this many seconds, this many minutes, like that. Okay, so 1 by time period is equal to frequency. Now 1 by frequency equal to time period. So this many t state into what I should multiply? One by frequency shall I multiply? So that what I will get? Total time period. Okay, so your microprocessor is working with, consider 2 megahertz, ma. Megahertz na, it is frequency or time period. 2 megahertz na, frequency or time period. Megahertz, it is frequency, because hertz unit is hertz, frequency. So 25 into 1 by 2 into 10 to the power of 6. So total time period is what, ma? (25 by 2) is what? 25 by 2, ma. 12.5. Here in 10 to the power of 6. If I take it to the what, numerator, 10 to the power of minus 6. So 12.5, 10 to the power of minus 6 now what? What unit? 10 to the power of minus 10 to the power of minus 6 na micro. Mega means 10 to the power of plus 6 ma. But that mega, it is in the denominator. If I take towards the numerator, it becomes 10 to the power of minus 6. So totally your answer will be 12.5 microseconds. So for completing this instruction, and if your microprocessor is working with 2 megahertz speed, 2 megahertz frequency, it takes to complete 12.5 microsecond. Did you understand this process? How to convert T state into seconds? Okay, ma'am. It's time up. If any confusion, few more instruction we will see, so that we will understand more clearly. Okay. Thank you, everyone.